All right, so here we go. We're stepping it up a notch. We've got our rational inequality. This one's a little different because we've got two rational expressions involved in this. We talked about how the two things that we're looking for when we're when we're solving this inequality are the vertical asymptote or asymptotes and the zeros. Okay? In order to figure out what these are, I mean, obviously we could probably take a look and figure out what our asymptotes here. We're not going to jump to conclusions on that. But as far as the zeros are concerned, where is the zero in this inequality? We don't have one. So if you're supposed to be finding these zeros to set up these intervals, then you have to set this inequality with 0 on one side. The way that's going to happen, because we've got this negative fraction right here, is we're going to add that to the other side. So what we're going to end up with, okay, is the sum of these two fractions less than or equal to 0. Right? It'd be much easier to figure out when this enormous sum is going to be equal to 0 if it was one fraction. All right, and let's go through the script. In order to add fractions, we need a common denominator. The fastest way to get a common denominator is to multiply them together. However, hopefully you notice that we've got a 4 in each one of these denominators. So even though I may want to multiply all of this by all of this, multiplying by 4, it's already here. Okay, and vice versa, it's already here. So that would be a redundant multiplication that I don't need to do. So notice the only difference here is that this is x plus 2, and over here we have x minus 2. So I'm going to be multiplying the fraction on the left by x minus 2, and on the top by x minus 2. Over here on the right, I'm going to multiply by x plus 2 and x plus 2. All right, let's see what we get. On the left side, we have x minus 2 over 4, x minus 2, x plus 2. Over here, I've got 3x plus 6, and then the denominator the same as the other side. Okay? As we go to combine these fractions into one, we have 4x plus 4 over 4, x minus 2, x plus 2, I guess I didn't write that so big, and this is less than or equal to 0. Again, what did we say from the very beginning? Asymptotes and zeros. This is what's going to help us establish what the intervals are for our inequality. All right? The vertical asymptotes are the zeros of the numerator. I'm sorry, the zeros of the denominator, my bad. And the zeros of the function are the zeros of the numerator. Why don't we tighten this thing up here a little bit as well? 4x plus 4, we can write that as 4x plus 1. Okay, so my zeros, again, the zeros of the numerator. When will the numerator, when will this equal 0? When x equals -1. My vertical asymptotes, when will the denominator be 0? These are the zeros of the denominator, 2 and -2. So what I get from this are my 3, let's call them boundary points, for the intervals of my inequality. I always start this at -infinity, and I'm going moving from left to right until I get to the first value of x on the number line. We have -1, we have -1, we have 2, we have -2. The first one I would approach if I'm moving from -infinity to the right is -2. I'll stop there. I'll pick up again from -2 to -1. I'll pick up at -1 and go to 2, and then I'll pick up again at 2 and go towards positive infinity. Now we're testing numbers in each one of these domains with this inequality, which is something that we've done a fair amount of up to this point. I think you can take it from here.